In other words, a polynomial is a finite sum of terms where the exponents on the variables are non-negative integers. Note that the terms are separated by plus s, plus apostrophe s, and minus apostrophe s. Alright, a polynomial is a finite sum of terms, polynomial, finite sum of terms, finite sum of terms, finite sum of terms. So this is basically infinite, basically infinite, basically infinite, or the exponents on the variables, exponents on variable, variable, exponents, exponents, variable, exponent, are non-negative integers. So I guess this wouldn't be negative, I guess this wouldn't be negative, I guess this wouldn't be negative. This is obviously not negative, this is obviously not negative, this is obviously not negative. I completely forgot how to explain this thing right here, so I'm gonna just skip that. Nope, that might have been the explanation what I just said, but I'm not sure. Alright, note that the terms are separated by plus apostrophe s and minus apostrophe s's. No, by pluses, and minuses, pluses. So in a polynomial, it's separated by minuses and pluses. See right here, section, plus divider. We're about to go to another section, section. Plus, we're about to go to another section. All the dots, or another section, plus, another section, plus, another section. Alright, separated by pluses and minuses, and these pluses can all be minuses to give different sections. As an example of a polynomial expression is 3x to the 5th power minus 5x to the 3rd power plus x minus 10. A polynomial expression, I think I said in the other video, is just a whole bunch of numbers and letters and pluses and minuses and all that. I don't know about multiplication, but I know for sure it's like pluses and minuses. A whole bunch of stuff chained together by pluses and minuses. A whole bunch of stuff chained together by pluses and minuses. A whole bunch of stuff chained together by pluses and minuses. Numbers and letters, numbers and letters, numbers and letters. Alright. Degree of a term. The degree of a term is the sum of the exponents on the variables containing the term. For example, the degree of a term is the sum of the exponents. Degree of the term, sum of the exponents. Degree of the term, sum of the exponents. Degree of the term, sum of the exponents on the variables contained in them. Of the variables contained in the term, on the variables contained in the term, on the variables contained in the term. Alright, on the variables contained in the term. My bad. I'm not even sitting up and I need glasses. I'm messing this all up. It's, you can understand it, but it could be a whole lot better if I was doing stuff differently. Anyway, if I was being more mature. Alright, for example, the degree of the term 2a b would be 1 plus 1 equals 2. The exponent on a is 1 and the exponent on b is 1, and the sum of the exponents is 2. Alright, the sum of the exponents on the variables contained in them. You know what? I could have just skipped that memorization. Well, it's good to memorize the phrases anyway, but I'm trying to think. Would it be better if I just said this once and then memorize this? Or was it better to memorize this first and then read this? Alright, whatever. Alright, the exponent on a is 1, 1, 1, 1. Exponent on b is 1, 1, 1, 1. And the sum of the exponents is 2. And 1 plus 1 is 2. 1 plus 1 is 2. 1 plus 1 is 2. 1, 1, 1. 1, 1, put together 2, put together 2, put together 2. Degree of the term, degree of the term, degree of the term. Bam, bam, degree, bam, bam, degree, bam, bam, degree of the term. Degree of the term, degree of the term, degree of the term. Sum of the exponents on the variables. A and B is a variable, A and B is a variable, A and B is the variable. Okay, the degree of 5y to the 3rd power would be 3, since the only variable on the exponent we have is 3. I'm rushing it. I'll just continue in the next video.